What is a graph? A graph is a data structure consisting of two main components, nodes or vertices. These represent the entities or objects, for example, people, cities, or web pages. Edges, these are the lines that connect two nodes, representing a relationship or a path between them. Graphs can be directed. The relationship goes one way, like a follow on Instagram, or undirected. The relationship is mutual, like a friendship on Facebook. They can also be weighted, where edges have values representing distance, cost, or time. Real-world applications 1. Social networks platforms like Facebook, LinkedIn, and X, formerly Twitter, are massive graphs. Nodes are users, and edges are friendships or followers. Graph algorithms help these platforms suggest people you may know by finding nodes that are closely connected but not yet linked. 2. Navigation and GPS, Google Maps. Road networks are modeled as graphs where intersections are nodes and roads are edges. When you ask for the fastest route, the system uses algorithms, like Dijkstra's, to find the shortest path based on the weights of the edges, distance, or traffic time. 3. Recommendation engines. Netflix and Amazon use graphs to connect users to products. If a node, user A, is connected to a node, movie X, and user B has similar connections, the system recommends movie X to user B. This is known as collaborative filtering. 4. The World Wide Web. The Internet is a giant directed graph. Every web page is a node, and every hyperlink is a directed edge. Google's original PageRank algorithm works by analyzing this graph to determine which pages are the most important based on how many other nodes point to them. 5. Logistics and supply chains. Graphs help companies like FedEx or DHL optimize delivery routes. By modeling warehouses and delivery points as nodes, they can determine the most efficient way to move goods across a global network to save fuel and time. 6. Cybersecurity and fraud. Detection banks use graphs to track transaction patterns. If a group of accounts, nodes, are sending money in a circular pattern, or are all linked to a single suspicious source, graph analysis can flag this as potential money laundering or fraud. 7. Power grids and infrastructure. The electrical grid is one of the world's most complex graphs. Nodes, power plants, substations, and individual homes. Edges, high-voltage transmission lines, and local distribution wires. Application, utility companies use graph analysis to prevent cascading failures. If one node, a substation, fails, the system can instantly calculate how to reroute power through other edges to prevent a total blackout. 8. Biology and genetics. Scientists use graphs to map the interactome, which is the complex web of interactions within a living organism. Nodes, proteins, genes, or molecules. Edges, chemical reactions or physical bindings. Application. By studying these graphs, researchers can identify hub proteins that are central to a disease like cancer. This allows them to design drugs that target specific nodes in the biological network to shut down a disease's progression. 9. Natural language processing, NLP. Graphs are what allow AI and search engines to understand the meaning of words rather than just the spelling. Nodes, words, concepts, or entities, for example, Paris, capital, France. Edges, semantic relationships, for example, Paris is the capital of France. Application, this knowledge graph allows an AI to understand context. For example, it helps a digital assistant know that when you ask about the Giants, you are likely talking about the sports team in your city, not actual mythical creatures. 10. Epidemiology and disease modeling. Public health officials use graphs to track and predict the spread of infectious diseases. Nodes, individuals, households, or entire cities. Edges, physical contact or travel routes between them. Application. By analyzing the graph structure, scientists can identify superspreaders, highly connected nodes, and determine exactly where to implement a quarantine or distribute vaccines to break the chain of transmission most effectively.